Morning, sir. Can I get a confirmation na visible na po ang nasa kong screen, sir?
Yes. Visible na siya.
Kasi naka-full screen kasi po, I cannot see. Wait lang, sir, ha? Medyo nag-lag siya sa akong end. So, wala rin may naka-hamper po, right? So,
Wala, wala.
okay, sir. Thank you so much, sir. Good morning, everyone. Good morning, classmates. Um, it is our honor to present to you our project proposal for this subject. So, to start with our introduction, so Philippines is very well known for being affected in terms of earthquake, and earthquake is not just a matter of a natural phenomenon that we can just ignore. Earthquakes can really cause detrimental effects not just in our infrastructures but as well as in our lives as well. So in just a matter of seconds, a lot of things can happen and a lot of accidents would occur. So in our study, we have decided to focus more on this aspect and relate it to how we can mitigate it as well and ensure that our buildings are built safer in terms of earthquakes. So again, this is our root data. So again, this is our project proposal and it's the analysis of earthquake data using Python. And once again, I am Engineer Dea Oden Laza and I'm together with Engineer Josephine Mary M. Laroga. So to start with our introduction, allow me to transition you or hand over you to Engineer Laroga.
Thank you, Engineer Danlaza. So, good morning, sir. Good morning, everyone. As for the introduction, it is well known that the Philippines is located within the specific Ring of Fire, a region with a high tectonic activities marked by frequent seismic events. More on daghan kayo og mga earthquakes na gakahitabo sa ato ang country, and these earthquakes could be destructive. Intense ground shaking can damage buildings and disrupt lifeline systems. Surface ruptures poses a direct threat in the integrity of roads, bridges, pipelines, which compromises essential mobility. That is why in engineering, we actually consider seismic loads in our load computations. So mitigation strategies rely on enforcing national structural code of the Philippines and adopting earthquake resistant design principles. So our study mostly focuses on analyzing the earthquake data, but with the technology right now, advanced data analysis methods, strengthen monitoring, and support practical steps to reduce the earthquake impacts, according to Peñarubia et al. In 2020. And then these analytical tools could provide location-specific rates to improve the accuracy of disaster risk assessments. Next slide. So, for the statement of the problem, the study seeks to answer the following questions. What are the relationships between the earthquake depth, spatial coordinates, and temporal occurrences using Python interpreting the data? How can primarily main shock events and subsequent aftershock sequences can be classified using these models? And how reliable are these models in seismic event classification and magnitude estimation? Next slide. For the objectives of the study seeks to attain the following objectives: to explore the seismic data analysis through Python, to classify primary main shock events and subsequent aftershock sequences, and to execute model development and systematic evaluation using performance matrix. Next slide.
Okay, wait lang po. Nag-lag akong screen. Sorry for the technical, sir. Medyo nag-lag siya. Siya mo next. Nilag si slides na ko, sir. Sir, sorry kayo, sir, ha? Sorry for the tech. Nilag, ni kalit siyang freeze. Dili na siya mo ano. For a while lang po, sir, and everyone.
Kuan lang tingali ma'am, highlights lang tayo sa result
Sige
tayo
po.
ng ka-detail
Sige,
sa
sir. Okay. I think goods na siya. Ibalik na siya, sir, no? So, again, I will just wrap this up in our methodology. So, first and foremost, we did data collection and as well as loading. So, in this portion, we actually gathered the open data sets coming from the Fibooks. And, ala, na-exit na noon siya. Sir, I'm very sorry for that, sir.
Wala problema.
Brag na sense niya ang kuan. Urgency and vitality. Importance sa event be magbuang-buang daw ko be. Wait lang kayo sir ha. Ni exit gid siya. And for our third is again the data pre-processing. In this portion we actually mag-share screen ko otro sir. Nalimot ko mag-discuss ng tato. I'm very sorry for that. So for data pre-processing, again, in this portion, we actually eliminated those data that are empty. So in our analysis, dili siya pwede ma-run, especially if na ay mga missing data. So what we did was to clean our raw data that we got from the website of Fivox. So for the third portion, it's the data exploring the data analysis. So we have here the three items that we did, and next is the aftershock classification. We categorize or classify the main shocks between the and aftershocks, and as well as model development, model evaluation, and again for the data visualization, it's the results, and these results are somehow animated, and again discussion of results and then conclusion and recommendation. So engineer job, so this is
Okay.
actually the python that we had the script. So next slide na lang po ta. Thank you.
Okay, so as for the results and discussion, we have here the following figures. So figure 2 shows the distribution of earthquake magnitudes. We have here a mean value of 2.48, and then the distribution of earthquake depths, which is 26.68. So we can see here that the magnitude usually ranges from 2 to 3, and for the depth, it's actually usually young mean is 28.68, so meaning more on the shallow side and less kayo ang deeper nato ng mga earthquakes. Then for figure 4, it actually shows the distribution by hour of the day. So we can see here that most of the earthquakes actually occur usually nighttime and kanang pakadlawon ang time. So it could be nga na ay effect ana ang daytime sa pag-record. So nasa machine. Next is figure 6, monthly earthquake frequency. So the highest number of earthquakes that was recorded was actually recently, that was on October 2025. And then the figure 7 shows the yearly earthquake statistics. So we can see here that medyo nidip siya gamay but i-increase ra po dayon siya. And then as for the average magnitude, the average magnitude of our earthquakes actually is decreasing. Next. For figure 9, the feature importance or the random forest classifier. So we can see here the different variables that was used to actually classify our aftershocks, whether it is a main shock or an aftershock. And then feature importance for magnitude prediction using random forest. So we can see top 3 latitude, depth, and longitude. Next. Figure 11 shows the temporal distribution of the aftershocks, and then figure 12 shows the spatial distribution of aftershocks. So it's the temporal, it actually shows the days after the main shock, while spatial shows the distance from the main shock. Then figure 13 shows the main shock magnitude versus the aftershock count. So we can see here in the table. And then for figure 14, random forest, it shows the random forest confusion matrix. So we have here the predicted label and the true label. Then for figure 15, we have the classification model comparison. So for the classification model comparison, there were three logistic regression, random forest, and neural network. So comparing the three, we can see here that for accuracy and F1 score, the random forest scored higher than the other models. Then for figure 16, next please. For figure 16, random forest predicted versus the actual. So we can see here the diagram. Then for figure 17 is the residual plot. And finally, this is the animation. So you can see here that by year, we can see the magnitudes of the different earthquakes that occurred in our country. So by year na siya nakakuha. So from 2017 to 2025.
So for our conclusion, so basically this research, these are the following conclusions that we have. Data processing and visualization effectively revealed meaningful patterns in relationship with the depth, spatial distribution, as well as the occurrences. Depth and spatial mapping proved sufficient for describing seismic activity and supporting informed interpretations across different locations in our and time periods in our country. And aside from that, modeling approaches successfully distinguish between main shocks and as well as aftershocks using the classification methods that we had. And reliable results dependent on thorough data pre-processing, no, and the selection of relevant parameters and systematic evaluation to ensure practical suitability in our analysis. And second to the last is the structure seismic analysis supports the prioritization of rapid inspections for national roads and bridges to maintain passability and public safety, and as well as future work involves linking seismic analysis with structural conditions records and additional geographical parameters to enhance the long-term monitoring of critical transportation system. So these are references, and to conclude this presentation, sir, we wanted to live with this idea that um, our aim as civil engineers is to ensure the integrity of our structures and to ensure the safety of our citizens and as well as the national bridges and roads. And we will utilize the data that we have today in ensuring the brighter and resilient tomorrow for the future. So I think that concludes our presentation, sir. Thank you so much.
Thank you, sir.
Okay. Thank you, Engineer Canlas and Gerald. I'm really impressed with this presentation. Although, kalau ano, alam, it's a boundary between engineering, computational methods and data analysis, but it's really impressing, sorry, impressive presentation. I just hope lang tingali ma-publish niyo ni or magamit niyo ni, nga, planning, di ba? Hopefully.
Hopefully, sir. Actually, we do not have any experience yet in uploading in well-known published websites or something, but we could see to it nga we would definitely be able to experience that what before we graduate our masters. Of course, we really have to
Okay.
explore and delve deep into that aspect, sir.
So, because the data you presented is very comprehensive. It's good.
Sir,
I think good enough na siya for publication. Mahanay lang ninyo ang kanang inyong methods of kanang results and the interpretation. I think it's really good for publication. Congrats.
thank you, sir.
So, okay, one applause reaction for Engineer Dinlaza and Engineer Laroga. So next, let's have Engineer